This is Algebra 1. We are on lesson 1.6. The title of the front of this is How Many Teams? My expectations for this worksheet is that you've already done this worksheet in small groups of 2 to 3, and you are now watching for the video solutions, or maybe if you need a hint. As a reminder, everything that is written in blue will be things that I was expecting you to write, and everything that is written in red you have to write because those are my teacher notes. All right, number 1, how many teams will there be in round 2? Well, there were 64 teams, and every time you move to the next round, each losing team is eliminated, so it's single elimination. So in round 1, there were 64 teams, but in round 2, half of those teams will be gone, so the answer now is 32. And it does ask you to explain, how do you know? So you'd say something like, because half the teams were eliminated. Perfect. And then now it's asking how many teams will there be in round 3. And again, half the teams should be eliminated from 32, so half of 32 is 16, and it's not asking for an explanation. And number 3, how many rounds will there be before the championship game? So we know that on round 1, it tells us at the very beginning that there are 64 teams. In round 2, we figured out in question number 1, that's 32. In round 3, in question number 2, we figured out that's 16. And we can kind of see that to get from one step to the next, we are dividing by 2. That's what I expect most students to see. To get from 32 to 16, we are dividing by 2. And we're going to go 4, 5, 6, 7, 8. So let's keep taking half. Half of 16 is 8, half of 8 is 4, half of 4 is 2, half of 2 is 1, which means there's only one team left after round 6. So there are 6 rounds, and after that 6th round, we are done. So, but it's asking for the championship game, not for the winner. So the championship game happens right here. That's when the 2 best teams compete, and after round 6, they're done. So how many games are there until this round? Well, after round 5, then we have only 2 more games left. So the answer here, it's a little bit tricky, but it's 5 games. So it's asking the number of rounds before the championship game. There is where the championship game happens. That happens right after our 5th game. All right, and number 4, does the same number of teams get eliminated in every round? And the answer here is no. Because in the first round, 32 teams get eliminated, bringing us to 32. In the next round, 16 teams get eliminated to bring us to 16. So I will say that the number of teams being eliminated also halves each time, each round. All right, and just, I think that's good enough. And then number 5, describe how the number of teams changes after each round. So let's cut in half. I'll just say cut in half, or something like that. And then number 6, plot the points that show the relationship between the round of the tournament and the number of teams remaining in each tournament. So in round 1, there are 64 teams. So in round 1, I'm going to come up to a height of 64. And then in round 2, there's half of that, 32. In round 3, there's half of that, 16. And then 8, and then 4, and then 2, and then there's just 1, which is, I guess, is like halfway in between. It's a little bit hard to see. All right, done. And number 7, what do you notice about the shape made by these points? So remember that in previous graphs, what we've had is something that looks like a straight line. There's no straight line that goes through all of these points. So we can say that it's not a straight line, but you can also say the points define a curve. you don't have, that's a kind of a fancy way of saying it. I'll just say it looks curved, right? So it looks curved. And I can also say these points at the very beginning are spaced out, but the points at the very end are really close to each other. So I'll say at the beginning, so at the start, spaced out, and at the end, they're kind of compressed. All right, so that's everything that you should have done. Now I'm going to go back through this from the teacher perspective and see what you were supposed to learn. So the first thing that I'm seeing is in the table in 3, while most people will probably say divide by 2, really what I want you to see is that this is the same thing as saying to get from 64 to 32, this is multiplying by 1/2. And notice that I've written this in red, which means that you need to write down everything that is in red. At every single step, while dividing by 2 is okay, more importantly, we are multiplying by 1/2. This is saying 1/2 of 64 is 32, or 1/2 of 32 is 16. So this is kind of the pattern that I want you to see. What do you multiply by? And the other thing that I want to see is whenever you're cutting in half each time, that is no longer arithmetic. And maybe someone had something that said there were 32 being eliminated, then there were 16 being eliminated, then there were 8 that were being eliminated. This has no common difference. So there's, and maybe you can see this in the table too. This is -8, this is -4. These numbers are not the same number, therefore there is no common difference. If there's no common difference, that means, so I'm doing a little arrow here, that means that it's not an arithmetic formula, or not an arithmetic sequence. An arithmetic sequence is like 1, 2, 3, 4. You constantly add 1, add 1, add 1, or 2, 4, 6, 8. You add 2, add 2, add 2. You can add or subtract for an arithmetic sequence. This is not one of those because these are all different numbers. There is no common difference. So the next thing that I want to talk about is what this actually is. When we constantly have words like in half or a percent, I'll also write this as well. Whenever you're doing a percent over and over again, or you're doing a half over and over again, or you're doubling over and over again, these multiplying numbers, these always mean you're going to be a geometric sequence, as opposed to an arithmetic sequence. So geometric sequences have something what's called a common ratio. Up here, this was called a common difference, and the reason that we call it common is because usually all of these numbers were the same, they were common. Now, this number right here, the multiplier, is common, so I'm going to say that this is still common. This common multiplier is 1/2, 1/2, 1/2. Okay, so where did this word difference come from? It came from taking this term, subtract this term. 8 minus 16 was a -8. That is the difference between this term and the term to the left. Well, now we're going to have to find this multiplier. How do I get 1/2? And the answer is I take a right number and I divide it by the left number. 1 divided by 2 is 1/2, or 2 divided by 4 is 1/2. I'm taking the right number divided by the left number, and I'll get what is known as the common ratio, because I'm doing division. Divisions are fractions. Fractions are ratios. So this is a common ratio. And in this case, the common ratio is the thing that I'm multiplying by. It's always the thing that I'm multiplying by. In this case, it's 1/2. Some people don't like the word ratio, so if you don't like that, you can say that the common multiplier. Although if you go up in higher levels, like in Algebra 2 of mathematics, I will be using the word common ratio as opposed to common multiplier. All right. The last thing that I want to say is because our common ratio is less than 1, so I'll just do an arrow up here. It's curved because this number right here is less than 1. So it's going to go down. If the common ratio, So I'll say if r was bigger than 1, if r is greater than 1, it would go up. And I can show you what that looks like really quickly with a sketch. If I had some quick axes down here, it would go up like this, as opposed to our graph, which is currently going down. But both of these are curves and curves when we're going up and we're going down. All right, so that concludes the front of the worksheet. Remember, everything that's written in red, you need to write as well. It's now time to move on to the back for some quick notes. Once I finish with the quick notes, then you will work on the checking your understanding on your own. Let's go. All right, so for the quick notes, today was all about geometric sequences, so I will write this out. Geometric sequences have a common ratio. The previous term gets, instead of added, it gets, and this is super important, multiplied, which is different than our common ratios or our common differences for arithmetic. Arithmetic was adding and subtracting. Geometric sequences are multiplying and dividing. So if you're trying to go from the left to the right, we're multiplying by the same amount. Each time, right? Same amount each time. So there's two things that can happen, and then we'll be done with the notes. So if the common ratio, by the way, we call this common ratio R. So if the common ratio R is between 0 and 1, that means, to arrow here, that the terms decrease. And Mr. Sandell, like, didn't you say that you just had to be less than 1? Well, we can't be negative. So I have a barrier here so you don't accidentally become negative. So you can't be less than 0. It's anything less than 1, but also greater than 0. And the other possibility is if the common ratio, I guess I could have just said R here, but again, the common ratio is still just R. If R is greater than 1, that means that the terms increase. All right, so that concludes the quick notes. You're on to the checking your understanding questions. Again, there's 2 questions, which really is 7 questions if you break it down. All you're deciding is arithmetic, geometric, or neither, and explaining why. Again, when you're using a reason, you should be saying something like there's a common difference, or there's a common ratio, or there isn't a common ratio or common difference. Remember, the way you find out a common difference is you do right term minus the left term. To find the common ratio, you're doing right term divided by the left term. And if those aren't the same, then it's neither. And I think that's a good enough hint. I'll see you guys tomorrow.